Hi everyone. In this section, we are going to learn how to construct confidence intervals for a population proportion. But before we talk about formulas, let's first answer an important question. What is a confidence interval and why do we need one? Suppose you want to estimate the percentage of adults in a city who own a smartphone. Surveying every adult would take too much time, money, and effort. So instead, we collect data from a sample. The problem is that one sample will not perfectly represent the entire population. If we took another random sample, we would likely get a slightly different result. So instead of estimating the population proportion with just one number, we estimate it with a range of values that's likely to contain the true population proportion. That range is called a confidence interval. In this section, you'll learn how to construct and interpret confidence intervals for a population proportion. Let's begin with a few important definitions. The population proportion, denoted by P, is the true proportion of the entire population with a particular characteristic. Since we usually don't know the population proportion, we estimate it using a sample. The sample proportion, denoted by p hat, is the proportion of successes in a sample. And the formula is p hat equals x over n, where x is the number of successes and n is the sample size. For example, suppose we survey 200 people and find that 150 own a smartphone. Then p hat is 150 over 200, which is 0.75. Since we use p hat to estimate the unknown population proportion, so p hat is called the point estimate. Another important term is the margin of error. The margin of error tells us how much our sample estimate could reasonably differ from the true population proportion. A smaller margin of error means a more precise estimate. We'll learn how to calculate the margin of error in the next video. Confidence interval is the range of values used to estimate the population proportion. And finally, the confidence level tells us how confident we are in the method used to construct the confidence interval. The most common confidence levels are 90%, 95%, and 99%. Now, let's answer another important question. When should we use a one-proportion-z interval? The answer depends on what you are trying to estimate. If you are trying to estimate a population mean, use t-interval on the TI-84 calculator. If you are estimating a population proportion, use One-PropZInt interval on the TI-84 calculator. A quick way to remember this is ask yourself, am I estimating a mean or a proportion? If the answer is a proportion, then use One-PropZInt interval. Before we construct a confidence interval, we need to verify three conditions. First, the sample should be random. Second, the observations should be independent. We usually check this by verifying that the sample size is less than or equal to 5% of the population size. Finally, we check the large counts condition. The condition is n times p hat times 1 minus p hat is greater than or equal to 10. Be careful here. Use the sample proportion, p hat, not the unknown population proportion. If three conditions are satisfied, then we can conduct a confidence interval. Now, let's check the large counts condition. A survey found that 156 out of 1,300 adults answered yes. Does the large counts condition hold? First, find the sample proportion. P hat equals x over n. X is 156 and n is 1,300. And that equals 0.12. Next, substitute p hat into this formula. I have n equals 1,300 and p hat equals 0.12. So I have 1300 times 0.12 times 1 minus 0.12. And I want to know if this is greater than or equal to 10. 1 minus 0.12 is 0.88. So I have 1300 times 0.12 times 0.88. And that is 137.28, which is greater than or equal to 10. So the large counts condition is satisfied.